In this lesson, we will practice converting between exponential form and logarithmic form. This is really going to help us when we get into solving exponential and log equations, and then also when we get into exponential modeling. So you're definitely going to be seeing this again. To evaluate a log, we try to determine which exponent on a given base that, when raised to another exponent, what the value is. It's kind of confusing with all the wording, but like once you get the rhythm of it, it's like exponent and base and all this weird stuff. But you're raising the base. All that's saying at the top is you're raising a base to a power to get the number. It's hard to explain, but we're raising this base to something to get 10,000. That's what I'm trying to say. Concrete example makes a little more sense. So 10 to what power is 10,000? And that's going to be 4 because there's 4 zeros. 10 to the 4th is 10,000. 4 to the what is 64. 5 to the what power is 1 over 3,125. Now the key here is you're focusing on the denominator, 3,125, and you're trying to figure out 5 to what is 3,125. Well, you can kind of use your calculator to figure that out. 5 to the 5th, well, that was lucky. 5 to the 5th is 3,125, but we're not talking about 3,125. We're talking about a fraction. In order to get a fraction, you need a negative exponent. So instead of 5, it's actually negative 5. 5 to the negative 5th power creates the fraction of 1 over 3,125. Last one, 4 to the what? To the what power is 1 over 16. Let's focus on 16. 4 to the what is 16, 2, but it's a fraction, so it needs to be negative 2. And that's all. That's all it's asking for. Isn't that neat? So you may just be given this piece, and it's asking you, what is that power that makes this expression true? And a good generic formula for this is you start at the base, raise it to the C, and you'll get A. So B to the C equals A. That's all. A common log, like in your calculator, is log base 10. We don't normally write 10. It's just kind of an understood, kind of like X has an understood 1 in front of it. Log has an understood 10 for the base. Now, if it's not 10, then it'll have an actual number there, like log base 2, like these up here. Log base 10, log base 4, log base 5, and so on. So if it's not 10, it'll be stated. And then a log in base E is actually called a natural log. That's a cursive L, so you don't think it's a 1. Natural log. A natural log has a log of base E. That's going to be useful later. I have some summarized rules here. We've actually already gone over a lot of these in the previous videos, so if you need to go back and look at those, you can. But I just kind of summarized them all here just so we can have it nice and neat as we move forward. Some of the key things we need to note here is that when you have 10 raised to a log of base 10, those are like inverse functions, and so they kind of simplify to 1, I guess you could say, and n drops down. Same thing here, log A of A, those are going to be like inverses, and they simplify and n drops down. Natural log E, natural log is base E, so those simplify and the n comes down. You might hear the word cancel We don't like to use the word cancel. That's like a bad word in mathematics, but if you say it, I will understand what you mean. And then we have our other properties that we should be familiar with at this point. We have a few examples down here. We're converting to exponential form. Exponential form has exponents in it. So we're going from logs to exponents. They're the same thing, they just look different, kind of like a reduced fraction. It's the same thing, it just looks different. We start with the base, raise it to what it equals, and then that equals x. And 2 to the 5th is 32. So we're saying 2 log base 2 of 32 is 5 because 2 to the 5th is 32. It all relates to each other. 3 squared is x. So x is 9, 3 squared. Try the next one, see if you can get it. Pause it, try it, come back. You should get 4 to the 1/2 is x. Remember that a fraction exponent, if we go way back to radical functions, radical expressions, rational exponents and radical, those are the same. 4 to the 1/2, long story short, I could go into that in a whole lesson of itself. But long story short, a fraction exponent means that it is a square root in this case. And it's a square root because there's a 2. If it was a 3, it would be a third root. It was a 4, it would be a fourth root, and so on. So long story short, that's what that means, which means that x is 2. 4 to the 1/2 is 2. Okay, try this next one. You're gonna have to do a little bit of solving on this one. 2 to the 5th is x plus 1. 2 to the 5th is 32. Then we subtract 1 and we get 31. So log base 2 of 31 plus 1 is 5, which makes sense because 2 to the 5th is 32. Pause it, try this one, and then come back and check your answer. You should get 3 squared equals x minus 4. So 9 equals x minus 4, add 4, and we get 13. Easy peasy, right? Last one, go ahead and pause it and try it, and then come back. You should have found 4 to the 1/2 is 2x plus 1. We know that 4 to the 1/2 is actually the square root of 4. Subtract 1, divide by 2. And you should have gotten 1/2. Not too bad. Now we're going to go the other way. So we've practiced starting with logs and converting to exponents. Now we're going to go the other way. We're starting with exponents and we're converting to logs. Now, in exponential form, you have a number with a base, and that base translates to the base of the log, which is here, the little guy. And then remember that the exponent was actually what it equaled. And so 1,000 goes here. And you can check yourself because we're comfortable with the exponential form. 10 to the 3rd is 1,000. And so that's how you can kind of check yourself. If you just run it back through the other way and it checks out, then you're good. So the next one, the base is 2, which means that when I write my log, my base is 2. And then my bigger fonted number goes here, and then my exponent goes here. So what we're saying is 2 to the 4th is 16. Easy. Not scary at all. Y'all go ahead and pause it and try this one. Write it in logarithmic form and then see if you get it right. We should have base 9 of 3 is 1/2, which means 9 to the 1/2 is 3. And remember, the 1/2 power is actually a square root, kind of hidden square root. Next one, try it again. Actually, I am going to zoom out. I want you to try the last 3 on your own. Pause it, try them on your own, and then come back and check your work. You should have gotten these log equations. In the first one, log base 5 of 1 over 25 equals -2. In the next one, log base 10 of 1 over 1,000 equals -3. And the last one, log base 4 of 1 over 64 equals -3. And that's all. That's all I have for converting exponential and log forms. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help.